Hi folks, in today's tutorial I want to take your data visualization skills to a new level and show you first of all how you can customize your 3D elevation maps with some cool color palettes, and then also how you can create very effective inset maps and put them together with your 3D elevation maps. Welcome back to R, where we will first of all install and then load the packages we need using the Pacman package. So the first thing we need to check here if this package is already there. So first of all, if this package is not installed on our system, we need to install it. And in order to install it, we simply use command install packages from base R, and then we simply say here that we want to install the Pacman package. Once we install the Pacman package, we can call a function here, which is called p_loads, and this is what it's going to do is basically it's going to load the packages if you already have them, and if not, then it's going to install them. The first one we need is the geodata package, which is going to help us get the shapefile of Italy on the regional level, and this is going to help us create our inset map. We'll be working with the Sicily, but we also need the map of Italy, which is going to be this local area map on our map. So that's the first thing. The second one is getting the digital elevation model, and for that we can use the elevator data, or the package which we used in so many previous tutorials. Then of course, because we are working here with a raster file, we need a Terra, and of course because we are here also dealing with the shapefile, we'll be also using the SF package for simple features objects. Of course, first of all, we'll be creating here a ggplot object, so the 2D map, and for that we need this tidyverse umbrella package where we also can find ggplot too. One of the things that we will do is of course create the legend breaks, and for that I always use the class int package, and of course we will create the 3D map, 3D digital elevation model map, and finally we'll put everything together, so both the 3D map and the local area map into one, and for that we can use a magic package also. Fetching the country and regional polygons is very straightforward if you use the geodata, and this is what we're going to do. First of all, I'm going to get the map of Italy, or actually sorry, the polygons of Italy on the regional level, and from geodata we can call one very important function which is called GADM. This is going to fetch the global administrative boundaries polygons, and it can be done for any country in the world. So we're going to be here specifying the ISO 3 code for Italy, which is ITA. And then in the next one, we'll be specifying the level here. So we want the first administrative level, which are regions in Italy. And then this is why we paste it here. So this is, among other ones, going to give us also Sicily as one of the regions. And this is also going to allow us to filter out Sicily or any other regions for that matter. And over here, we're going to simply say that this file is going to be downloaded onto our main working directory. Now, this is not going to be in the SF format, so we need to coerce it. And that is pretty straightforward if you use this st as SF function. Now, if you want to then inspect what you actually got here, you can easily do that. So you can simply plot here the geometries of this region SF. And what you will get once you run this whole chunk is the map of Italy with, of course, regions. Now, what we want to do next is we want to filter out the region of interest. And as we said, we would like here to fetch Sicily. So what we're going to do first is we want to make sure what is, how this looks like and what is actually that we need to filter out. So first thing that you can do right away off the bat is that you can simply go ahead here and inspect what this region has. So this one has, among other things, it has the names of these regions over here. So it's called name_1. So we can use this one to filter out. Now, we don't know whether this is written in Italian or in English, these names. So we need to actually check what it is. And to check, it's very straightforward. We can simply print out all of these 20 regional polygons. So we use print, and then we pass here a region SF or regions SF that we previously created. And then we here specify how many rows we want to be returned. So I say here 20, so these are all the rows, and I'm just going to show you here how this actually looks like. It's pretty straightforward. So I'm going to print this regions SF, and what you can see here is actually 20 rows for each of them. So if you circle back, you can see here that it says it's Sicily. So we're going to use Sicily here, and we're going to use this field name_1. All right, let's actually do that. So let's call this one region SF. So not regions, a region SF, because we're filtering only one region. And then let's use subset from base R. So from this one, we want to pass actually a regions SF. So these are all the Italian regions. And we want to also take here name_1 when it equals to Sicily. And also pay attention here that this is a string. You want to put a double quotation marks here. All right. Once you do that and run this, you can go ahead and see what you actually got. So you can also plot this specific region. So region SF. You can also do it like that, and you can then run this whole chunk, and then once you plot this, you should be able to see only Sicily, so only the island of Sicily as a region. All right, this is not all, because we also need the country polygon here, because we will be using that one for the final map, of course, for the inset map at the end, which is going to be much smaller than the map of digital elevation model of Sicily, but nevertheless, it's very important for us. So this third object we're going to just call country SF, and this one is we simply need to union all those regional polygons of the original one. So we're just going to pass here regions SF. And then once you run this, you can also plot once again this one. So now what you can see once you plot this country SF object is the map of Italy, but without the regional boundaries. All right, we have the regional polygon. The next thing is to fetch the digital elevation model for Sicily. And this is going to be very straightforward, because we can use the elevator package to fetch this for us using the getElev_raster function. So here what we need to do is, first of all, specify locations. This is the name of the polygon that you're going to pass. So here we use, of course, region_SF, which is the polygon of Sicily. The next one is the Z argument. This is the resolution. So it goes from like 1 to 14. And here you should be careful. The bigger your region, you want this to be actually smaller. So I chose something like 9 because Sicily in itself is not that of a large region. The last thing is how you want to crop this raster that you're gonna get. Do you actually want to clip it as a bounding box? So that means in our case we will be getting also the sea around Sicily, or we just want the Sicilian boundaries. So I want only the Sicilian boundaries, and that's why I choose here that I want to clip by locations. Now, Italy is a European country, and when I map European countries, I use the Lambert equal area azimuthal coordinates reference system, and this is what I'm also going to do here. So I just pasted it here. If you're working with some other country, you can go to epsg.io, type your country, and then also search for the coordinates reference that you need, or you can simply look at one of the previous tutorials where I explained this. For now, what we want to do is make this a string object, because this is how R can accept different coordinates reference system. And then here I'm just going to call it CRS_Lambert. Okay, the reason why we did this is that I would like to reproject this Elev file, Elev object, and I'm going to create here Elev Lambert. So the first thing I will do here is I'm going to put this into a pipe, and then I'm going to coerce this into a Terra Rest object, because I would like to work with Terra. And after I do that, I can simply use Terra project to, of course, reproject, and then simply pass here this object CRS Lambert. Since we will be passing this to ggplot2, we need to make sure that it's in a data frame format. So our next step is to coerce this raster into a data frame. And in the process, we will create a new object. Now to coerce, we can use asDataFrame. Then we pass this Elev Lambert. And finally, we also say that we would like to create the coordinates in 2 columns, X and Y, and the third column, which is going to be the value of the elevation. Now, if you actually create this, the third column is going to be some weird name. So you can change the name of the third column in this LFDF, passing something like this, and then also specifying here that you want to change the name for the third column, and we can call it, for example, here DEM. Before we jump straight into creating the 2D map, let's define our legend breaks and also the colors that we'll be using in ggplot2. Now, for the breaks, what I usually use here is the class-in package, which has a function called class intervals. This is going to create natural intervals for your breaks based, of course, on your data. And the first thing that you need to do is define here the data frame from which you're taking, and then, of course, the field or the column from this data frame. The second object or the second argument here is the number of breaks you want to have. I'm going to have here 7. I usually go for the number between 5 and 8. And then the final one is the style. So this is how you want to divide actually how you want to create your legend breaks. I'm going to go here for the pretty style, which simply involves rounding your breaks. And then finally here, you simply want to say that from this list, because this is going to be list, you want to take the object which is breaks. Now that we have this, we can define also the colors. For colors, I like to use HCL colors from base R. So over here, I'm going to define the number of colors based on the length of these breaks. Basically, that means the number of breaks is going to correspond to the number of colors and vice versa. That's the first one. The second one is the palette. Now here I found one very cool palette, which is blue and red. And blue I want to use for lower elevation, and red I want to use for higher elevation. So you can check it out. I'm going to provide a link in the description box to the colors of HCL colors. So this one is called Ziso, I hope I'm pronouncing this well, Ziso 1, that's the name of the palette. Now what you can also do, and what I'm going to do here, since this is a continuous measure, and the colors can also be continuous, I'm going to go and create here a texture that you can use. The texture will increase the number of these base colors. Of course, it's going to be based on the colors that we defined here, but essentially using this color ramp palette, I will be able to expand this, and you can expand to 100 and something, 200, whatever. I can even go ahead here, specify, let's say 512 new colors. Okay, let's make that map, and we can call this object map. We can call then ggplot function, add plus here, and then start adding our first layers. So once we're here at this ggplot one, we can simply say that our main data here is LFDF, and then we can use geom raster to specify this first layer. Now here we're going to have our main aesthetics. We're going to use here the X field for the X coordinate, Y field for the Y coordinate or the latitude, and then finally fill. For that we're going to be using this den. Okay, so that's the first one. That's the first and only layer actually that we're going to have. Now we can go ahead and customize certain things. The first thing that we can customize is, for example, the color here. So for that we can use this scale fill gradient, and with the colors that we already have, we can go ahead and pass them. But first things first, let's for example first define the legend title. So we are here having elevation in meters, and I'm going to just put that elevation in meters. The second is the colors. So we have the texture that we can use, or if you prefer that lower number of colors, you can also pass here colors. Then for the breaks, we can use here breaks that we previously also defined. And then you can also define here labels. So labels, these are going to be the way the legend breaks are printed. And what I like to do here is I like to simply round the breaks themselves and round them to 0 decimal places. Okay. And then finally, what you can also put here is the limits of the plots. So you don't want just to include the breaks themselves. You also want to include all the way to from the minimum to the maximum value in your data. So what we actually are passing here is two elements. So the first one is the minimum of your LF underscore DF and the DEM field. And then the second one is the maximum value here. Again, we are using this in order to, of course, put the limits of our legend so that we include the full range of all the values that are there. Once we have this, we can also go ahead and work a bit with the legend itself. So this is handled by guides. our argument. So here what we just put is the fill equals to guide color bar. Now guide color bar is used for the continuous measure, and in our case digital elevation model one is the continuous. So we can, for example, define the direction. Direction can be horizontal or vertical, and I'm going to go here for the vertical one. So that's the first thing. The second one is how high this is going to be. So because it's a vertical, I would like it to be quite high. And for that purpose, I can, for example, define here in units that I want this to be, let's say, 30 millimeters. The same way we define the height of the legend keys. To be more precise, we can also define the width of the legend keys. But here we want this to be actually a bit thinner. So maybe we just go, let's say, for 3 millimeters, so 10 times thinner. And then you can also define other things, such as, for example, title position. I can, for example, put the title on the top, so I can put that. You can also define a label position of your ggplots, and for that we can, for example, say that we want them to be on the right side since it's vertical. You can also put it on the left side, that's fine. You can also here define the title horizontal justification. Values go from 0 to 1. Basically 0 is the left hand side, 1 is the right hand side, and this is mid, this is centered. You can also do for the labels, so label .hjust, and they can also be 0.5 or anything else. You can also play with the number of columns or rows, and also you can put here whether you want the legend keys to be next to each other or not. Okay, so this is more or less using now fine-grained options in ggplot2 to further refine, specify our plot. But one thing that is also very important here is if you are defining a coordinates reference system, it's very important that you also tell ggplot2 what is your coordinates reference system. So what you can do here is you can define this coord SF, and then within CRS, you can here define CRS Lambert. If you're using something else, you're naming it in a different way, or you're not using it at all, maybe you can just unpin this part. Okay, and then we come to the part which is quite interesting because it's about customizing the background of your plot. So here I'm going to go for the theme minimal, which is going to get rid of most of the things. And then within theme, I'm going to specify some additional things. Now the thing here is I would go usually for theme void, but because we're going to pass this to rayshader, and rayshader doesn't really work well with theme void, I need to go ahead here and specify things. So one of the things that I want to specify here is access lines. So I'm gonna here go ahead and remove them, and to remove something from ggplot2 or to make it not really appear, you need to select here element blank. So that's one thing. There are other things that we can also remove. So for example, access style X, we can also remove that. So we don't want, you know, X and Y to show up. So for that purpose, I'm going to do the same for also the Y title on the Y axis. I just need to change here instead of X to have it to Y. That's also that. And then I also don't want reticules to show. So for that purpose, I'm also gonna do the same for the axis text X and axis text Y. So I'm just gonna go ahead and paste this here. Okay, now that we have this, the question is, what else can we also add here? So you remember that we are working here with the legend. And one thing that we could do is specify, for example, legend text or legend title for that matter. If you want to specify certain text within ggplot2, you need to define here that this is element text. And then once you do that, within these, you can specify the size in pixels. You can also specify the color. Let's say, for example, we go for charcoal gray. The same thing that we did here for legend text, you can also do for legend title. You only need to change here the name of this attribute here. And then for the title, maybe we can go for 10 pixels and actually decrease the one for legend text to 9 pixels. Speaking of legend, we should also here define a legend position in our plot. One thing that you can do is you can simply write here top, bottom, right, or left position, but you can also select the position in space based on the coordinate points, which go from 0 to 1, or actually better said from -1 to +1. Now, the way this is defined is the first argument is x. So basically this is how it moves horizontally on your plot. So I would like it to be very close actually to the left-hand side. And that's why I'm going to choose a bit smaller here value, which is 0.1. But I like it to be high. So I would like the legend to be, which is vertically positioned, of course, I would like it to be in the upper left corner. That's why here I need to choose a way higher value, such as, for example, 0.85. So this is taking these two. We will have our legend in the upper left corner at the end of this after running this. Okay, so these are some of the things that you can define, and there are also some of the things that you should actually remove from your plot. And some of them are called grids. So there is a panel grid major and panel grid minor. So actually, instead of removing them, what we can do, so these are lines, so we need to tell ggplot2 this is element line. What we can do is we can actually color them into the background of the plot, which is going to be white anyways, but we are not going to fill them, so this is going to be NA. And this pattern we can then also apply to the other argument, which is called panel grid minor. So I'm just going to go ahead and paste this here. So this actually deals with the grids in the plot, but apart from grids, there's something which is also called background. So the plot itself has a background and the legend has a background, and we need to deal with that. Both backgrounds are specific type of elements, which is a rectangular element, so you also need to specify here. So the rectangle itself has the borders and has the filling, and that's why they're both things like color and fill. So what we can do here is we can choose for the color that it's going to be white, and then for the filling we will simply go and choose here that it's missing. Now for the legend background, it's going to be a bit different because I would like the legend itself to be a separate entity and also to have a bit of a shadows. So what I'm going to do here is, after defining this as a rectangular object, I'm actually going to say that the color here should be missing, but that we should have the filling here, and that the filling should also have the white color. All right. Once we define these different types of, backgrounds, a very last thing when it comes to discarding some things is called panel border. So this is what is going to be around the panel itself where the map is. So this is again the rectangular element, so we need to define that. And once again, same as we did for the plot background, the color of the panel border is going to be white, but the filling inside of it is going to be missing. And then the very last step is not about removing, but it's about specifying the margins of your plot. And the name of it is also plot margin. So this one I use it quite often because it's very handy at defining what is going to be that extra space around the plot. So what I like to do is simply suppress that space around the plot, and simply here I define 0 values for each of the elements, each of the sides, of course, of the plot. And then I also here define the types, which is not that important, but it's important in that context because unit argument requires that you also specify this. Of course, this one needs to come within these brackets here. Okay, and then once you actually have this in place and you run this whole thing and then print, of course, this map object, you should be able to see the digital elevation model of Sicily together with the legend in the upper left corner of the screen. And we can finally use rayshader to render the scene with, of course, the use of the ggplot object that we created. The first thing I would like to do here is actually define the height and the width of our plots that we will pass then to rayshader. So the easiest way is for the height here that I'm going to create, simply calculate the number of rows of your LF Lambert object, which is that raster, and then for the width, simply calculate the number of columns also for this LF Lambert object. Once you have that, you can call to rescue a rayshader, and specifically its function, which is called plots_gg, which is used for rendering scene based on ggplot2 objects. So let's first of all pass the name of our ggplot object. So this one is called map, and then you can pass here the width and the height. Now for the width and the height here, you need to pass in inches. And if you pass here this width object, one thing you will see is this is too high for 4 inches. Well, what you want to go for, if you're working with inches, you want to go for a single digit number. So you can, for example, divide this by 1000, but then it might be too small. What you can do instead, you can divide this 2.8K, you can divide with 500 instead, and then you can get something decent. So if you do that, this is going to be around maybe 6 point something inches, and that's totally fine. Now, if you're doing this for height, so if you're dividing it with a certain number, you should also do it with height as well. So both width and height should be divided with the same number in order to avoid distortion of your image. So that's quite important. The next argument is how spiky this is going to be, and the default value is 150. Now this is going to be too spiky, and that means that the shadows in the background are going to be very stark, and I don't want to happen there. So what I'm going to do here, and I'm going to decrease this 3 times. So from 150 to 50, if you're asking me what these numbers mean, it's not really intuitive, so the best thing to learn is to actually apply this and then see how this looks in practice. So I'm going to go for the value of 50 of this scale. One thing that I want to avoid here is rendering that panel around the map. So I don't want the shadows to appear around it, only want for those values of the elevation. And one thing, of course, that we want here is we want to enable shadows. So shadow equals true. We can, of course, choose different things when it comes to shadows, for example, shadow color. What I like to do is I choose the white shadow color, because then the shadows are not so strong, those in the background. You can also choose to minimize this, the effect of the shadows as well by decreasing the shadow width to, for example, 0. And the final thing that you can do is you can also define here shadow intensity. By setting it to 1, the shadows become very, very pale in the background. All right, so there are other things that we can define here. One of them is the zoom. I want to give this actually a bit higher zoom. In a sense, I want to zoom out a bit. That's why I'm putting here 0.7. The reason for that is since we're going to have this inset map, I want to create some extra space for it. So that's why I'm zooming out this one. Then you can also choose the degree of your, of course, of your scene. I'm going for almost a normal degree here. If you want a bit of a different degree, you can, of course, set here. This is, of course, quite optional. And then you also want the rotation around your plots. What is going to be? I'm just going to set it to 0, so basically no rotation around it. And then finally here, you can, of course, choose what is the window size. Now for the window size, you can finally define this one in pixels. And what I like to do is I can, for example, use these values that we have for the width and the height. Now this can be actually quite big in this case again. So the window might be huge. So what you can actually choose here is to maybe decrease a bit. So you can maybe decrease this, let's say 4 or 5 times. Let's say we just simply decrease this 4 times. So you can simply divide this one by 4. Of course, this does not universally apply. If, of course, your raster file is much greater, you should also reconsider what you will be using here. And once we rendered our scene and we are happy with its looks, we can go ahead and render this object. So in this tutorial, we'll be using once more a customized light source from the Polyhaven website. And this is actually to link to one of them. This is the source of the warm lights. It's called Photo Studio Log All 4K. And this is a link to it, which I'm also gonna include in the description box below. But for now, we are gonna turn this into a string so that we can first of all download it locally. And I'm actually gonna call this one URL. That's the first thing. The second thing is to, of course, download this one. We can use a download file and specify here the URL name. Then, of course, the destination file. Now, this one, what I would like to do is simply fetch the file name from the link itself, and that's very easy. You can simply use here base name of your URL. So the destination file name is then going to be this HDRI file. And finally, we want to use the binary mode to download this. Once you run this, you will download the file to your working directory. So the next step is then simply to call this once we render the object. So let's actually do that. So the first thing I would like to do is, first of all, define here the file name. So the file name we can call, for example, 3D Sicily, and very importantly, we want here the extension of your file, extension name, which is going to be a PNG file, and only then we can go ahead, call rayshader, and from rayshader we call a render high quality. So over here we specify the first thing is the file name. So this is the file name. That's the first thing we specify. The second thing you specify here is whether you want to see the preview or not. So I do want to see the preview, so I also select this here. We also want to have the lights in the scene, so the lights are set to true, and then we are using here environment light. So environment light, and what we are passing here is going to be this HDRI file, which is directly going to call that file that we downloaded locally. So here you can select one of the things for it, which is called the intensity of your environment light. Imagine that the intensity of 1 is a default one, and then you can choose whether you want to increase or decrease. So I already tried before this source of light, and if we go with 1, it's pretty strong, so your scene is going to be very, very light. So I decided to decrease by 40%, so to keep it at 0.6 here. Okay, then one thing that I like to turn off is the interactive mode, which actually allows you to move the scene as it renders, which can often crash your current session. So I try to avoid it. And then here you can choose, of course, the width and the height of your image that you want to render. And for that, I'm using these dimensions of the raster file that we already have. Okay, and then after a few minutes, once you run that chunk and you render your object, you should be able to see finally the 3D digital elevation model of Sicily. Now, the next thing we want to do is to add that inset map of Italy, which shows the area using the red rectangle, the area of Sicily, which we are showing actually as a part of a bigger map. So the first thing we need to do here is we need to create two polygons, which are actually bounding boxes of 2 units. We need to create the bounding box of the Sicily itself, but we also want to create the bounding box of Italy as a whole, which is going to be a sort of a frame that is gonna discern this inset map from our main map. So let's first of all create a bounding box for Sicily, which I'm gonna call here region B box. And this is very straightforward. So what you need to do here is you need to first of all, from this asset package, use this function. And then you want to apply this because this function is gonna actually coerce anything to a polygon object. So what you want to use here is you want to create here a bounding box of that region underscore SF. So once you run this, you will actually create a bounding box, which is at the same time a polygon in the SF format. So what we did here for Sicily, we can replicate and create the Italy bounding box, which I'm going to call country B box. And here, instead of the region, you simply pass here a country SF. So these two are going to create 2 polygons, which are bounding boxes for both Sicily and then Italy. And in this section, then we can create also the inset map using this newly created object and some past ones. And once again, call to rescue ggplot2. So let's create inset map. Again, we call here ggplot. And then we add several layers. Of course, we're working with SF object. That means we need to here use a geom_SF function. So the first one that we will add is the map of Italy. Of course, this one is the polygon without regions. So I would like actually the borders of the Italian one to be white. Basically, they're just going to blend with the background, which is also going to be white. And then I want to fill actually the polygons here with a very light gray color. Of course, this is all optional. You can customize in your own way. And then finally here, I want to choose, let's say, the size of the boundary strip. Not so important given that anyways, this is going to blend with environment, but this is just for you if you want to change, for example, the thickness. Though I do feel like you should here go for, especially if the version of ggplot2 is newer, you should actually aim for line width here instead of size. Okay, so we can actually put the minimum one, maybe even to 0. It doesn't really matter. So this is the first polygon. The second polygon we want to add here, again using GeoMSF, is the country bounding box. So this is going to be the frame that is going to discern our inset map. So this is the country B box that we previously created. And this one, I need this one to be transparent when it comes to the filling, because otherwise we won't be able to see Italy within that frame. So that's the first thing. And then the second thing is what is going to be the color of the boundaries. I'm going to go ahead and choose here again light gray, because I don't want these boundaries to be super visible, but I still want something that is gonna separate this inset map from this digital elevation map. So that's also one of the things that you can define. Of course, here you can define the thickness of it. Since it's very light gray, the line width can be actually a bit thicker, so that's totally fine. And then the third and the last one is basically adding that a rectangle which is going to separate the region of Sicily. So again, we call here GeoMSF, and then finally for the data, we choose a different object, which is region_B box. So here again, we do want this filling to be transparent so that we can actually see Sicily. And then for the color of this rectangle, we're going to go, for example, for red. It can be anything else, but I'm going to go for red because we do also have the red in the plot, so it's not like standing out that much. And finally, for the line width of this rectangle, I'm going to go ahead and choose something even thicker so that it's going to be completely visible on the plot. And then finally, we can wrap this up using theme void, which is going to get rid of any background material. Okay, you can go ahead then and actually print this inset map. First of all, run this chunk and then print, and then you should be able to see the map of Italy with accentuated a red rectangle around Sicily. So we have now everything in place. The only thing what we need to do is to put all those maps together. And to put them together, we can use actually magic. So this is our final step here. We can use magic. And first of all, we first of all need to call these images that we previously saved. So if you haven't actually saved this one, we can go ahead and save it using ggsave. So that's gonna actually save us some trouble. So first of all, we can go ahead here and come up with some name for this second inset map. We can just call it maybe inset_map, and then we use here PNG. So that's the first thing. So then we can pass here to the name of this, of course, object that we want to save, this file name that we already defined here. The second thing that we want to do is choose here the plots. Our plot is called inset_map. And then you can define here, of course, the width and the height. We used that before, so basically we just divided here by 500 to get some decent value in inches. And we did also for the heights, we also need to do this to avoid the distortion. And here for the units, we can define here inches, but if you're not comfortable, you can also work with millimeters or centimeters, whatever is fitting for you. So you can then run this and finally also save locally. The reason why we are saving locally is that magic works in a way that you load images into R that are previously saved. And this is what we're going to do also here. So we're going to actually go ahead and from magic itself, magic package, use something which is called image read. So in the image reads, what you need to do is you simply need to pass the name. So the name is in this file _name. It should not be mistaken with the one which is the region digital elevation map in 3D. For that one, we define file name as a single word. And again, we'll be just using here this magic imagery. So why not just copy paste this, rename, of course, this one into file name. So once you actually run these two, this is going to load both images. So both the inset map and the main map of the digital elevation model. Okay, So the next thing that you want to do here is you want to rescale a bit or scale down this legend a bit, because as it stands now, it's actually quite big. It's maybe the same size as the main map, and you don't want that. You want that to be much, much smaller. So what you can do here is you can use a function from Magic, which is about rescaling. So it's called image_scale. So within this one, what you want to do is pass this inset map image object. And then here you need to choose what is going to be the size in pixels. All right. So I'm going to go here and choose something like, let's say 1200 pixels. I think anything you choose lower, it's fine. It's just the image going to be smaller and smaller. It really depends on your preferences, how big you want this inset map to be. Okay. Once you have that, you are actually ready to put things together. And putting things together using Magic package is handled with the help of one function, which is called image composite. Image composite, what it does, it takes your images, in our case it's just 2 images, but it can be more. It takes them and then it puts them together in the way that you envisage. So what you want to do here is you want to take first this one, so the main one, followed by this inset map, so that we rescaled over here. And then what you want to do here is you want to define what is going to be the place on that map. Now, if you remember that map that we previously created, the main map, you will see that there is some space in the lower right corner. So that is southeast. Southeast we can define here using this gravity, where you don't need to simply define here as southeast. If your image is, different, you maybe have some space, I don't know, in the north or in the south, you can also specify that. So all the possible sites of the world and also combinations of them, such as this one, southeast, southwest, northwest, northeast. All right, once you define that, you can also do some offset. So you can move your image up or down. And this is handled using this argument here. Now, if you want to move something, you can use this plus or minus, depending if you want to move it north, south, or west, east, then this is going to affect it. And of course, you can change the values here. The reason why I have 2 here is the first one changes how your image moves horizontally, so on, along the x-axis. And the second here value manages how it moves along the y-axis, so basically how it moves vertically on your plot. So I'm not going to move it here at all. I just want to keep it southeast, which means the lower right corner. So once you actually have this, you can simply save this image, final image, to your drive. And to do that, you use image_write from the Magic package. So here we just pass this name, so it's final image. And then what you also pass here is the name that you want to assign it. We can, for example, go and call it final image.png. And that's all for today, folks. I hope you had fun and learned something interesting along the way. In today's tutorial, we created a 3D elevation map of Sicily together with the inset map of Italy. Now, if you would like to replicate today's analysis, I prepared the link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, reuse it, modify it as you see fit. I'm also looking forward to your own projects and how you can take this tutorial to some other destinations across the world. If you have any questions, comments, or just general feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your data visualization and geospatial knowledge in R, I prepared a few cool tutorials for you, so do check them out. See you next time.